Good morning, everyone present in the class. Very good morning to all. Great. Hmm. So, welcome back. We are in the concept of multi-threading. In yesterday's class, we started the discussion, and today we shall continue. If someone is new for the class, please rewatch whatever we have discussed so far. We started the journey from absolute scratch. From the world of transistors, semiconductor technology, we have reached till multi-threading in 2 months of time. So conceptually, syntax wise, you may have to watch whatever we have learned so far in order to understand the concepts. Fine. So where did we stop the last class, guys? What is the concept you have learned? In the synchronized environment at a type, how many threads will run? One thread. All of you present in the class? Yes, no, maybe. I would like to go back to my program where we had written this, and I'll go back and let me open the workspace. I'll say here finishers. Synchronized method, more on the locking in the tomorrow's class. Also, I will discuss two more examples, and I'll start with one of the most important concept, which is states of thread, a life of a thread. Okay. So my Eclipse is getting opened. All right. So multi-threading is the concept which we are exploring. And we have reached to a position where we have came to one thing, that in synchronized environment at a time, only one thread will operate. Now that is the one of the major difference between string buffer and string builder. String buffer, all the methods are synchronized. String buffer, no builder, they are non-synchronized. Fine, all of you guys. Look at the message here. If I apply this synchronized to let me just create one thing here, a new class only, so that I need not to make changes and you can maintain a file. I would like to go back to launch 7. I'll give the class name as 1, and I'll go and make it as 1 here also. Okay, that's all, nothing more than this. Great. Look at this, guys. I have applied synchronized to the method level. That means entire method, more than one thread cannot operate at a time. Concurrently, they cannot. Whichever thread gets the chance, it is not under our control. We have to start the thread. Whichever thread gets the chance, they'll go here. And if they get into the synchronized environment, synchronized method, even though if there is a delay, the thread scheduler will not be able to schedule any other thread. Making sense, everyone present in the class? Yes, no, maybe. Now, guys, look at the message here. Can all the childs of a parent, Ramesh, Suresh, Dinesh, at a time, if they get into the parking lot, as any problem is there here? Any problem, guys? At a time, they can get into the parking lot. At a time, they cannot drive the car. So whatever resource they are trying to access, right? In that, some part of the resource, all threads can access concurrently. There is no problem. Are you getting it? And some part of the task or resource, multiple threads cannot access at a time here. Now all three can get into the parking lot. There is no problem into that. But all three cannot get into car and drive at a time. So common resource, multiple threads. Are you all understanding here? Yes. So what I'm going to do is, I'm going to just say here, synchronize. Currently running object address is maintained by which keyword in Java, guys? currently running object address is maintained by which keyword in Java? Absolutely than this keyword. I am going to say whichever thread gets a chance for currently running object, I'll say this. Now, I'll go back. I'll remove this here. If I remove this here, guys, this run method, can that be executed by multiple threads at a time? Can that be executed by multiple threads at a time? So will you get any problem in executing this part of a resource has entered the parking lot? How many threads will operate this part of the code? Multiple threads. Let me just run this. I'll say right click, run as. Constant interaction should be there. It is a live class. You will also learn and it is good for everyone. Guys, are you able to notice here? Ramesh, Dinesh, Suresh has entered the parking lot. Now who got into the car? Is it all threads or only one thread? Then Suresh. So can we apply lock to a specific part of the code? The answer is yes, we can do that. Are you all getting it? Yes, no, maybe. Everyone in the class. So more on this I'll tell you with respect to debugs also. Class level locking, method level, object level locking. Synchronize is used to apply locking. At one point in synchronized environment, only one thread will operate. We have understood. We need to understand more on this. I'll show you debugs and what happens behind the scene in the upcoming 2 classes. But for now, to start the journey, I hope fundamentally synchronize means what you can know. You have all understood. Lock also specific part of the resource also you can lock. Entire part of the resource also you can lock. Is that fine? Everyone present in the class? Now, the most important part. States of our thread. Every time you create a thread, it goes through certain state. It is in the new state. It is in the new state. Then we have something called as runable state. Runable state. Then we have something called as running state. Then we have something called as dead state. Dead state, once the task of a thread is over, thread will go or thread will die. When it is at the running state, thread can go to a block state. Most of them feel it is one common block state. Actually, it is different only. We have something called as wait state. We have sleep state. New state, runnable state, running state, dead state. Understand this. Whenever you create a new thread, it will be in the new state. The moment you start the thread, it is in the runnable state. Now, whom will get a chance? We don't know. Whichever thread will get a chance will start executing the run method. So whichever thread is a run method, the thread is in the running state. Once the task of a thread is over, then it is in the dead state. That means thread is dead now. Thread is okay. Again, it will reopen. Let me reopen this. Oops. All right, let's rewrite once again. New state at what point, guys? Whenever we create a thread, new state. Whenever we start the thread, runnable state. Whenever thread is executing the body of run method, task of, it is in the running state. Whenever thread is done with its task, it is in the dead state. While it is in the running state, it can go to a block state. It can go to the wait state, sleep state. All of you present in the class? At what point, whenever you create a new thread, if you start runnable, if thread is executing the body of run method, running, task of a thread is over, dead. It can go, when it is running means when thread is executing the body of run method, that time it can go to the block state if required resource is not available. It can go to wait state if it is encountering wait method. Wait and notify, I'll come back to that. It will go to sleep state if it is encountering one method called as sleep method. It will come out of the sleep state when the sleep time is over. Required sleep time is over. It will go out of the block state when the required resource is available. Required resource is available. It will come out of the wait state when it encounters one method called as notify or notify all. I will talk on these terms, need not to worry. After sleep state, again thread is not going back to running state, guys. It is in the runnable only. Again, thread scheduler has to schedule, it will go back to the running state. You have to keep that into the mind. So basically, you can see here, guys, whichever thread is getting the chance, they will run the body of the run method, right? They'll try to execute the run method. If the required resource is applied log by one other thread, that means the remaining two threads will be in what state? Lock state. While it is in the running state, it can, if it is encountering sleep method, it will go to sleep state. After this, again runnable. Thread scheduler will schedule again the running. It will continue the running from that moment. If you are part of the journey so far, yes, no, maybe all of you. So I would like to take one example here directly. I'll write one code file. Suppose, guys, there are 3 books, one each in quantity. We have a Java book, we have a DSA book, we have a Spring Boot book in a library. Single quantity, only one Java book is there in the entire library. Only one Spring Boot book is there in the entire library. Only one DSA book is there in the entire library. And 2 students are trying to access it. How many students are trying to access it? 2 students. So how many students are there? 2 students. How many books are there? 1 book. So single resource, how many threads are there? Multiple. Now, not using properly synchronized keyword, what it lead to? And in the process, I want to demonstrate one example for which I am writing this. Understand to the best of your listening skills. I would like to go back and say thread 8. I'll go back here. I'll go back. Guys, maybe I'll write one class here. I'll say here class, whatever example I'm taking, deadlock. I'll say library. I'll say implements runable. This example I myself had created in 2018. From 2018, the same thing I'm been demonstrating just to show how deadlock looks like practically. Okay. So whatever task is there within the run method, we may have to, for some of the company I had recorded also this content. Now please here. I have 3 resources. I will say here string type of resource 1 equals to new string. I'll go and say the resource is Java. Likewise, I have three resources. Three books are there. Resource 2 we have. Resource 3 we have. I'll say here DSA. I will say here maybe Spring Boot. Three resources are there. And for which I'll do one thing. I'll go back here and create the object of library first of all. Common resource is there. Type library equals to new library. After which two threads I'll create. Thread type thread 1 equals to new thread. After which thread type thread 2 equals to new thread. How many threads are there in our application? Two threads. Do I have authority to give a name to them? Do I have authority? 100% yes, we do have authority. All good, everyone? I'll go back and I'll say thread 1 dot set name. I'll give the name as whatever name you want. I'll say here maybe student 1. Likewise, I'll give one more thread name. I'll give it as student 2. Student 2. Okay now? After which, right now, is there any life for a thread, guys? No. Both of them are in the new state. Right now, both of them are in which state? New state. I have just created it. The moment I start the thread, it will go to run a bull state. That means it can run now. It can be scheduled at any time. I will say here thread 2 dot start. Both of them are in the runable state. Now, whichever thread gets the chance, they'll execute the body of run method. That means they are in this state? Running state. Once the task of a thread is over, they'll go to which state? Dead state. All good so far? Yes, no, maybe. I'll go back here and say whichever thread gets a chance, they'll execute the body. Yes, we need to pass the library reference. Good that you have reminded. Thread, you have to do the task which is there inside the class called as library. I'll go back and say here, I'll say here thread dot current thread dot get the name. I would like to, whichever thread gets the chance, we don't have control. We have seen in the last class. I would like to get the name of that. I will say here string type of name. After which I will just check if in case name dot equals to maybe student 1. If it is equal to student 1, it should be the same student 1. If it is equal to student 1, I'll do something. Else, of course, we have only two threads here. For the student 2, I need not to check. I'll do something here. Exactly, Fabian. You're right. 100% right. Now, guys, we have two students, right? Already, if the student 1 I'm checking, by default, the else part will be executed by student. All good so far? I will say a try first only. And I would like to go here and say catch. I would like to say here exception type of E. Done. Maybe E dot print stack trace. I'm keeping the arrangement ready. Whatever code I have written is very simplified, which we have understood for almost every code file. Guys, if it is a student 1 thread, whatever part is there inside the if block, that will be executed. If it is a student 2, whatever is there in the else block, that will be executed. Now, both the students are searching for this book inside the library. One Java book is there, one DSA book is there, one Spring. Both of them want all three books, but only one quantity is there. Both of them are start searching. Whichever threads get the chance, they are searching it. And the moment they get it, they'll acquire it. Fine. So now, searching for some time, I'll say a thread dot sleep. They are searching for this book. They are searching for the book. Maybe I'll go and say here, starting 3 seconds. The moment they get the book, they will acquire log to it. I'll say here synchronized. I will say here resource 1. After acquiring the lock within the block, as long as the control is within the block, no, the resource is under the control of whichever thread is executing this. As long as the control never comes back out of this bracket. Okay. Acquire the lock to it. Resource 1. After acquiring the lock, it will make one announcement. System.out.1 println. I'll say student 1 has acquired. I will say here plus resource 1. Announcement made. After resource 1 is announced, it will not stop. It will start searching for one more book, which is DSA. Thread.sleep. That means it is searching for few more seconds. The moment after searching some time, suppose it is getting a chance to get the book called as resource 2. Apply the lock to it immediately. Synchronize resource 2. After doing that, it will make an announcement that it has acquired the resource 2 also. Again, after acquiring the resource 2, it will not stop. It will start searching for one more book. After that, maybe sometimes they could able to find that book. Immediately, they'll apply the lock to it. Synchronize resource 3. And again, after acquiring that, they will make an announcement that we could able to acquire resource 3 and then read that book for some time and release it. Release means the moment control comes out of this, resource 3 is released. The moment control comes out of this, resource 2 is released. The moment control comes out of this, resource 1 is released. Suppose student 2 gets the chance. If part will not be executed, else part will be executed. So whatever code is there in the else part, that will be executed. Instead of student 1, student 2 will acquire the resources. Done. Now, please see very carefully, guys. I would like to run this application. I'll say right click, execute this application, run this Java application, run as a Java application. Kindly understand this. Guys, student 1 has acquired the Java. Student 1 has acquired the Java. Now, student 2 will release the books. Student 2 will acquire the Java. At a time, that resources, is it getting occupied or acquired by multiple threads or only single thread? Multiple threads. Right? Whichever thread is getting the chance, multiple threads separately, concurrently only one thread. Now, guys, I'll go back to the states of thread. Let's understand this in the process states of thread. New state. Guys, how many threads are you creating? Student 1, student 2. All of you agree? After this, which ready state or runnable state? Both of them are same. In the runnable state, how many threads are available? The moment you write the start method, student 1, student 2. After which thread will get a chance? Are you sure of that? Which thread will get a chance? Are you sure about it? Whichever thread gets a chance, they will try to go and get into the running state. All of you agree on this? The run method. At a time, at any given point of time, only one thread will be available in the running state. That means who's executing the body of run method. At a time, only one thread will be there in the running state, not multiple threads. It is executing thread.sleep. It will go to a state called as sleep state for 4 seconds. That time now no one is there inside the running state. Thread scheduler will schedule student 2 thread. It goes there again sleep. Student 2 also has gone to the sleep state. After 4 seconds is over, both of them again will get back to the runnable state. It will not go back to the running state. It is again runnable. From there, thread scheduler has to schedule. Now, if they schedule again student 1 thread, it will continue the execution from whatever position it has gone to sleep state. That time, please see very careful. Look at the program here. Look at this program, guys. Again, maybe it was a thread 1. If block is there, after the sleep state is over, it will apply lock to resource 1. Resource 1 is applied lock by the thread 1 for an instance. So whatever resources we had, resource 1, the Java book is locked by whom? Student 1 thread. Okay. It will try to acquire, it will further go ahead, guys. After acquiring the lock, please here, it is making an announcement. After announcement, again the sleep state. That means after acquiring, it went again to the sleep state. Since it is in the sleep state, right now in the running state, no other thread is there. So thread 2 will get a chance. Thread 2, if it is getting a chance, please here, if in case, if it is not equal to student 1, it will go to the else part, right? In the else part, my thread 2 will try to acquire lock for the student 1, resource 1. Is resource 1 available or is it applied lock by the student 1 thread? Is it available, guys? Yes, no, maybe. Applied lock by resource student 1 thread already. Then, if at the time of running state, if the required resources are not available, it will go to one state called as block state. Now, thread 2 will wait in the block state. It will wait on the block state. It will come out of the block state only in one case, if the required resources are available. Now, as long as the thread will not come out of this, it will keep on waiting in the block state. Other thread is continue executing this, even though if there is a delay of 4 seconds, other thread will not be in a position to, right. Now, guys, please here, I will print one message here. All of you understand this, okay? I will say system.out.println. I will say here, student 1 got into library. Okay, I'll go back here. Student 2 got into library. I'll run this example. Please see here. Guys, at a time, both of them got into library. Now, student 2 has acquired the lock. That time, tell me one thing. Student 1 doesn't have any resources. It is in the block state. Once it is coming out of the, it is releasing the resources, only then the other student is able to acquire the resources. Are you all able to see this? Right way of using the synchronize keyword. If you don't use synchronize keyword properly, suppose cleverly, since synchronize, student 2 is acquiring the lock first, no. So what happens here? If he's trying to acquire lock for 1, if he's trying to search for Java first, Spring, DSA second, Spring Boot third. So what this thread will do is, it will try to acquire Spring Boot first, then DSA, then Java in the reverse order. Understand this to the best of your ability. All of you present in the class. Now, what happened in this case, please understand. Both of them got into library. No issues. Student 1 thread acquired the Java, student 2 has acquired Spring Boot. Because after which here, you wait for 2 years, program will never execute. Deadlock occurred. Which scenario? Deadlock. What is happening here? You need to understand states of the thread. Deadlock. Why deadlock? You wait for 2 years, it will not proceed further. This scenario is called as deadlock. Is it proceeding further, guys? No. Why it is occurring actually? You need to understand this to the best of your ability. All of you present in the class, focus here. Guys, see here. Everyone in the class, same diagram I will take, and please try to understand, okay? I'll go back. Finally, once the task of a thread is over, they'll go to a state called as dead state. All fine. Guys, 3 resources are there. We have a Java resource, we have a DSA resource, and we have Spring Boot resource. All of you agree on this? Yes, no, maybe? 3 resources are there. Java, DSA, Spring Boot. Correct? What is the order of acquisition at this stage? What is the order of acquisition of resources at this stage? Thread 1 is acquiring in what order, guys? Thread 1 is acquiring resource 1 first, resource 2 next, resource 3 next. Student 2 order is resource 3 first, 2 and 1. All of you? Yes, no, maybe? Reverse order, correct? Student 1 is 1, 2, 3, 3, 2, sorry, 1, 2, 3, 3, 2, 1. This is the order. Whichever thread gets the chance, they are in the running state. I'll make an assumption student 1 is got the chance. Student 1 order, it will acquire lock for Java. After which I have told thread.sleep, it will go to sleep state. That means right now in the running state, other threads are not there. In order to utilize CPU's time cycle, thread scheduler will schedule one more thread. Student 2. Student 2 is trying to acquire lock for resource 3. Resource 3, is it available for student 2, guys? Is it acquired or it is available? All those who are listening to me, please do respond. Everyone in the class. Acquired the lock. If you know Core Java so far, you could be able to understand. Partial focus is never allowed in any technology learning. Remember this. We are not learning A for apple, B for ball. We are learning technology. Right? All of you, we are getting associated with the tech. Here, utmost focus is required. The world is going very far. AI, cloud, DevOps, the demands are high. And we cannot get stuck in variables and simple programs. All of you are there in the class. Have you seen the program, guys, if you know Core Java so far? What is the order? Resource, is it available, guys? Is the required resources available? Available. It will apply lock. It was applied lock by student 1. It is applied lock by student 2. Again, I've told thread.sleep, it will go to the sleep state. Once the required time of sleep state is over, they'll get back. Again, they are in the runnable state. Again, thread scheduler will schedule. It will happen so fast that there is a high possibility both of them are completing the sleep state at the same time, came back to the runnable state at the same time, and again any thread will get a chance. Whichever thread gets a chance, they'll continue the task. Assume student 1 thread only got the chance. It will continue further. It will acquire the lock for resource 2. After which thread.sleep, it will go back to the sleep state. And since to utilize the CPU's time cycle, thread scheduler will schedule student 2 thread. Student 2 thread will continue and trying to acquire lock for resource number 2. See here? It will try to acquire lock for resource number 2. Is it available, guys? Is it available? Or already acquired by student 1? Not available. If it is not available, it will go to which state? Lock state. Now, guys, after the required time is over, student 1 will try to continue. Student 1 thread will try to continue. It will now try to apply lock for resource 3. Is it available for him? Resource 3, is it available? Already acquired by whom? Already acquired by whom? Are you all there here? That means if the required resource is not available, it will go to which state? Block state. Now, both of them are in the block state. To come out of the block state, what is required? Required resources must be available. Now, for a student 1 to come out of the block state, he needs resource 3, which is available with student 2. For a student 2 to come out of the block state, he needs resource 2, which is available with student 1. Due to cyclic dependency of the resources, they are permanently stuck in the block state. Whatever resource, see, for a thread to come out of the block state, whatever resource is required, it is available with student 1. For a thread 1 to come out of the block state, whatever resources are there, which is available in thread 2. Due to this mutual cyclic dependency, they will be never be able to come out of the block state and they are permanently stuck in the block state. So due to cyclic dependency of the resources, if multiple threads are stuck permanently in the block state, this phenomena technically we call it as deadlock in multi-threading. Deadlock is such a phenomenon in multi-threading where multiple threads are stuck in the block state permanently due to cyclic dependency of resources. Whatever resource student 2 is required, it is there with the student 1. Whatever resource student 1 is required, it is there with the student 2. I'll go back here. I will run this program, guys. Right click, run. You can see here. Both of them got into library. That's fine. Student 1 has acquired Java. Student 2 has acquired Spring Boot. Student 2 has acquired DSA. Now, student 1 needs DSA to proceed further, right? And student 2 needs Java to proceed further. Both of them are permanently stuck in the block state. You wait for 1 year. Let's wait for 1 year. It will not further move ahead. You wait for 2 years. Nothing will happen in the program. Wait for 1 year. I'll keep on waiting. Nothing. Are you all there in the class? Yes, no, maybe. What is a solution for deadlock? Solution for deadlock is proper usage of synchronized keyword. Proper use of synchronized keyword is the solution for deadlock. In the earlier program, guys, I have used synchronized keyword properly. Did it create any problem? It was working smooth, right? So how to avoid deadlocks in multi-threading? Proper usage of synchronized keyword. Using synchronized keyword properly will make sure that there is no deadlock in your program. All of you. There is something called as live lock also. If it was in the possibility of coding, I would have demonstrated. Where multiple threads will be in the block state, not because of the mutual dependency, in a different state. If resource 1 is not available and we execute only one thread, then will no deadlock. Why will be deadlock in that case? It is multiple resources, single resource, multiple threads. Only then the scenario will come, Akash. And the two last program, if you have seen properly, I've used synchronized. There was no deadlock. Last example, just before this. Single thread means why there will be that deadlock. Okay. Everyone present in the class. Look at this, Akash. I have demonstrated this. Since you have not focused, I will tell you for one more time. See here, Akash. Resource 1 I'm acquiring here also first. Then at the last, I'll acquire the resource 3. Okay. See here. Suresh, I have told you have not listened. Guys, what is the solution for deadlock? What is the solution for deadlock? Synchronize keyword. Suresh, you got your answer? That means if everyone is answering, that means did I answer in the class and you have not focused? Yeah, understand this, Akash. Now student 2 is acquiring Java. It has already acquired Java. Student 1 will try to also acquire Java. It is not available. It is in the block state. So it will release the lock. Then student 2 will get a chance. Student 1 will get a chance. There is no deadlock here. It is running smoothly. Understanding? Huh? It is running smoothly. I'm using the synchronize keyword cleverly. No problem. All of you present in the class. Guys, it is, you know, suppose, there are holidays from this batch, 2, 3, 4 days of holiday we have planned before the spring boot. So that time, you and your friend, I'll make an assumption that 2, 3 of your friends have joined this course together at once to learn and get into the job. And during the course itself, all of you, all 3 friends don't have a job. They'll go to their hometown back in the holidays, and maybe they will plan to visit a restaurant. If it is a daytime restaurant, if it is a nighttime also restaurant, but the type of the restaurant will differ. They'll go to the restaurants and they'll order everything and they will eat it. At the end, waiter will come for the bills. All 3 don't have a job. All 3 are undergoing the course. You are looking at your friend's face. Your friend is looking at the other friend face. Other friend is looking at you. None of them are proceeding. Waiter is waiting. None of you are proceeding ahead. All of them are stuck. This scenario is called as deadlock. None of them are proceeding. You are dependent on your friend. Your friend is dependent on other friend. The other friend is dependent on you. Due to the cyclic dependency of paying the bills, none of you have money. All of you are jobless. You're looking at waiter is waiting. And later, if it is in India, what will happen if you don't pay the bill? You and I both know personally. So that is a secret. After that, suppose you got the job after some time, 6 months of time, you are dedicated, you are practicing. You are not doing the course for formality to avoid the time. You are doing the course to really get skilled. And you'll keep on updating your GitHub profile and resumes and preparing for interview on a daily basis. You got a job. All 3 friends got a job. Again, going back to the same restaurant, and that waiter might be looking at these fellows again came who will never proceed with the payment. Again, this time what happens? All of you order everything, you had it, and the waiter comes with the bill. This time you're telling, I'll pay the bill. This is my bill. It's my treat. Your friend says, no, 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 it's my bill. I'll pay the bill. Again, one more friend, no, 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 it's my time. I will pay the bill. All 3 are fighting with each other that I'll pay the bill. I'll pay the bill. But none of them are paying the bill. This example is called as live lock. If it was possible with respect to a demonstration of the code, I would have shown. Deadlock code also will not find anywhere. I have just to show you that nothing is executed. I have played some cleverly and I've shown you. Actual solution for deadlock is using of synchronized keyword. We can avoid the deadlock. But using synchronized keyword, I have achieved deadlock. Just to demonstrate you what is the meaning of deadlock. I have created this example, and this example will not find anywhere. Nowhere. No courses, no YouTube, no documentation. Nowhere. I demonstrated, I have shown. Getting it? So live lock means where all of them are ready to pay, but no one will pay, no one will proceed. They're permanently again stuck in the block state. All 3 are fighting with each other. I will give you, I will give you, but none of them are giving. Understood the difference, guys? Deadlock, live lock. Everyone present in the class. All of you in the class. Are you all there? Yes, no, maybe. Okay. Fine, guys. Let's proceed ahead. States of threat. All of you are able to understand what is the states of threat. Whenever you start a thread, it is in which state, guys? Whenever we start a thread, whenever the thread task is over, it will be in which state? The task of a thread is over. Which state? All of you. And one more question. It is in the dead state. At a time, at any given state, there can be multiple threads present. But in the running state, at a time, only one thread will be there. So multi-threading is all about parallelism or it is about concurrency? Concurrency. If it was about the parallelism, at a time in the running state, one thread will be there, multiple thread will be there. Multiple thread will be there. But right now, how many threads in running state? Are you all understanding, guys? Everyone? Yes, no, maybe. Correct, Fabian. 100% dot correct. All right, guys. Let's demonstrate one more, guys. Lot to be understood. Today's class, tomorrow's class, and Friday's class also, we may have to discuss the same only. It's not yet over. So tomorrow and day after tomorrow also multi-threading. Because many things are there which I want to discuss. It's not over yet. Okay. And after I discuss that much, again, there are demands to learn more. I'm recording multi-threading Udemy course. You may get that detailed. But after I complete the Friday, I will tell you what you have to learn by yourself. Because as I have told you, I can spend 6 months for Java. But our course is Java plus Spring Boot plus microservices. If I spend 6 months with Java, then when Spring Boot, when microservices, and I'm pretty sure none of you will sit in the class for 1 year to attend the Java courses. It's not worth also. So already 2 months is over. We started the core Java. Somewhat we should have an end. If we keep on discussing, Java is so much rich in features. Every feature we can discuss and we can just go and go and go and go till 3 months, 6 months, 7 months, 10 months. We have to start Spring Boot. How many of you are actually excited to start the Spring Boot journey, guys? All of you? 14th October is a tentative date for the Spring Boot journey. What is the tentative date? 14th October. Okay. If some of your friends are there who want to understand the Spring Boot, they know core Java, or they can revise the core Java, or they can watch the recorded videos and get into Spring Boot and microservices live course. And if you feel I can try my best to make them understand and get comfortable with the Spring Boot, please do refer to them. Okay. All of you. Let them also come and join for the Spring Boot, classes. No, yaar, Suresh, that much gap. According to me, 4 or 5 days is sufficient because 2 weeks gap means then you'll forget who am I, where are you, in which planet you are in, then what is happening in this world, what is Java. I mean, I hope you're able to understand. If so much gap is there between two classes, no, then it will be a problem. Gap, guys, if I take class on Monday, suddenly the next class I'll take on Friday. Gap is there. That will not be, that much gap is not required. Okay. How much time? More than 3 months, Suresh. Minimum 3 months I need, but 3 to 4 months approximately. 3 to 4 months of time. Okay, because lot to be discussed there. All right. Everyone in the class. Yes, no, maybe. Can I proceed further, guys? All of you? If all of you give me permission. Guys, there is something called as daemon thread in Java, and your garbage collector is a daemon thread. That means a secondary thread. That means a background thread. At the end, after executing all the threads, at the end, it has to execute at least once. During the other thread's execution, it can also get executed, no problem. But daemon thread at last has to do one thing. At least once it has to get executed. Once the execution is over, at last, at least one. That means garbage collector will collect a object. In between, if there is any referenceless object and other threads are running the program, that time that garbage collector can collect the referenceless object. But it has been trained in a way that at last, once everything is over, at least once it has to get executed. Are you getting it? So let's try to implement the same thing here. I'll say here anything. Class MS Word. I'll say implements runnable extends thread. Both of them are same. I would like to go and say extends a thread. Anything is fine. Right now, if I create the instance of MS Word, will it create thread, guys? Will it create a thread? 100% dot yes. I'll go back here. I will say override. Okay now, everyone. I will create some threads, guys. I'll go back. I'll create some threads. I'll say MS Word type MS1 equals to new MS Word. All right. I'll take this. I'll go back MS2. I'll say here MS3. 3 threads are there right now. Do I need to explicitly create the instance of thread? No, right? Not required. 3 threads are already there. I will say ms1 dot set name. Set name. I'll give the name of this thread. MS Word, guys. What are the primary activities there? Many activities are there. Just to demonstrate, typing, checking the spelling, saving. Correct? These are the major activities can I consider. Typing, checking the spelling, saving. Okay. MS1, the thread 1 activity is typing activity. Thread 2 activity is spell checking activity. I'll give the name of a thread as spell. Thread 3 has to do saving. Thread 3 has to do the saving. Thread 2 have to do the same. Okay. Please understand this to the best of your ability. After which I will start all the thread. Dot start. MS2 dot start. MS3 dot start. 3 threads also I'm starting. All good. Everyone, guys. Now I'll go back. I will write the 3 activities. Public, void, maybe the activity is typing. Method name I'll give it as typing. Likewise, I have 3 different activities. One is spell checking, and one more activity is auto saving. Okay, now 3 activities are there. I'm going to use thread dot sleep. So possibly checked exception guy will come and create the problem. To calm down the checked exception guy, I'm going to write try and catch first only. Okay, pa, you be happy. I will listen to you. I know exception will not come. But if checked exception guy comes, why simply to, make him sad? I'll go back. I will keep this ready. Exception handling, everyone knows very well. And guys, if someone comes for the first time, looking at this code, whatever we are writing, it looks, oh my God, so much of coding. But if you are attending since the beginning, anything is there inside the code, guys, which you cannot understand. Can you read out what is happening here? All of you. Any difficulties there? Whatever you can see right now on your screen. It's all easy. Java is something which will not create ambiguity unlike JavaScript. And even Python, if you develop a complex applications. Sometimes an expert JavaScript developer will not happen why the application is behaving like that. If someone is from the JavaScript background, can understand. I will say less than 3 I plus plus. Okay. And I will just say system.out.println one message. I will say typing. After which, after typing, I'll say thread dot sleep for some 3 seconds. I will take out this. I'll go back and I will demonstrate everywhere. I'll go back and demonstrate everywhere. I will say here type checking or spelling checking. Spelling check. I'll just write here one quick message. Debuggers in tomorrow, day after tomorrow, I'll show, and producer, consumer, wait, notify all. Communication, intra-thread communication. Very commonly asked interview questions if you say multi-threading. So that also I'm going to discuss. I'll say here auto saving, auto save, auto save, auto save. All right, guys. I would like to demonstrate, understand this. I'll say run as Spring Boot Java application, Java application. Okay. All right. Oh, I have not defined the task no inside the run method. My bad, guys. I have to check, right? Thread dot current thread. Whichever thread gets the chance, I'll get the name of the thread. I'll get the name of the thread, not the priority. Dot get name of a thread. Name of a thread. I'll store that inside a variable called a string type of thread name. And now I will check which thread. If in case name dot equals to name dot equals to, if it is equal to type, I want typing activity. Yesterday's class, have we demonstrated, guys? Single run method, multiple threads. If it is type, then I want it to invoke one method called as typing method. Else, if I will check, else if I will check if it is equal to spell checking, then it has to invoke one method called as spell check method. Which method? Spell check method. I'll take this to avoid the spelling mistakes. I will demonstrate here. Okay. Else, if it is not spell, if it is not type, by default it is auto saving. So I'll invoke this method called as auto save. Very simplified, readable code, guys. I would like to now demonstrate this. Right click. Are you all there in the class? There is an error, it seems. Where is the error? Error is here. I'll go back, right click, run as Spring Boot application. Guys, first auto saving, it seems. Maybe printing I have done wrong. Typing, spell checking, auto saving. Oh, sorry guys, my bad. Are you able to see this? Are you all able to see this? Why there is a bug in the output? Have you got it? This bug because of one silly mistake. Not naming variables correctly. How important it is, I hope. See, just because of one data type integer flow happened and it created the issue for one of the European rocket long back because of one integer overflow. Ariane 5 rocket failure. Ariane 5 rocket failure. Just do the documentation, okay? Ariane 5. Now, guys, I'll go back here. How important it is typing, spell checking, auto saving. Typing, spell checking, auto saving. Spell checking, typing, auto saving. Guys, at last it is checking first spelling, then typing, then auto checking. This phenomena is called as race condition in multi-threading, where multiple threads will race towards the completion without bothering which thread has to get executed, what should happen. There is no control over it. See, first to last means auto saving, it seems. Then type check, spelling checking, it seems. And lastly, typing. Is it acceptable, guys? Is it acceptable? Are you all there? So whatever is starting 2 times, let it happen. But at the least at the end, at least once the typing and the spell checking and auto saving should get executed. That means they are secondary threads. They are the background threads. They are the daemon threads here. Not synchronized. I'll make them daemon thread. I'll go back and say Typing is my main activity. And spelling checking in saving is the secondary background activity. I'll say here, ms2 dot, there is something called as set daemon. I will make it as true. Hey, you are a daemon thread. ms2 dot set daemon. I'll make it like you are also a daemon thread. ms3. And I will set their priority less. What is the default priority of a threads, guys? 5. I'll make it even more less. I'll give it as maybe 3. And ms3 will give it as 4. Guys, in case of priorities, it is reverse. In case of ranking, guys, rank first is high, rank 10th is low. In case of priority, rank 10th is high, priority 10 means, oh, it has high priority. 1 means low priority. Are you getting it? If I say priority 3 and or maybe let me just check the default priority of these threads, guys. It could be maybe same only. The priority is also same as ranking. It is high possibility is there. Okay, my bad. But I'll check default priority of even the new threads are also 5. In the last class also we have seen it. But I have set this priority 3, I have set this priority 4. I've made them as daemon thread. In order to make any thread as daemon thread, you have to call the method called as set daemon and pass it true. Apart from that, the priority must be lower than 5. That means 1 to 5. Make it not make it more than 5. It is 1 to 5 the priority you have to give for those threads. Apart from that, yes. Apart from that, I've told 3 and 5 less than 5. Default priority is 5, right? I'm making that it is 5 priority is higher and this is lower priority. That is a message I try to give here. All of you present in the class, or maybe I'll make it this as 4 and this as 3. Okay. Now, guys, not just that, whatever activity you have defined for the daemon thread, it has to be under the infinite loop. Guys, which activity is taken care right now by the daemon thread? Out of 3 activities, which activity is the daemon thread and which activity is the main thread? A priority, normal thread, primary thread. Which activities I want to be taken care by a daemon thread? Which are the daemon threads, guys? Which are the daemon threads? So the daemon thread activity is there. No, I will keep it within infinite loop. Usually, guys, if you keep anything within the infinite loop, it will run for infinite times. Infinite times. That's the beauty of it, because it is run by daemon thread, not by a normal thread, not by main thread, not by primary thread. This will be running by the daemon thread. If you keep within the infinite loop, it will not be executing multiple times. Normally, if you keep something in the infinite loop, it will execute forever, infinite time of. But if you keep anything within the infinite loop, usually executes infinite number of times. If you give activity for a daemon thread inside the infinite time, it will not execute for infinite number of times. It will follow the primary thread activity. Okay, not typing is not a daemon thread activity, so I'll not write that. The other two threads activity, I will write inside the infinite loop. Okay, this is infinite loop. Spell checking is infinite loop, not the typing. Okay, typing is normal. Typing is a normal activity. Spell checking is a infinite. Spell checking is a infinite. Understand this. Infinite means any number of time usually. However, guys, they are now executed by not primary threads or main thread. They are getting executed by a daemon thread. And daemon thread follows the route of primary thread. Primary thread executes 3 times. The daemon thread also will execute 3 times. Even though I have specified infinite time, you can see it will not execute infinite time. That's the demonstration of daemon thread here. That is really they are the daemon thread. Please understand this. Typing, spell checking, auto saving. Spell checking, typing, auto saving. Let it be. At last, Let me define the task for one more time. Auto saving is happening at least once. Are you able to see these guys? At last, finally. At least once they are getting executed. Typing first, then only spell checking and auto saving. Doesn't matter in between daemon threads how many times they execute. But daemon thread will make sure that at last, once they will get executed after the primary thread. Even if you execute for multiple times. In between, however they want, they'll execute. But at the end, please see here. Guys, typing, auto saving, spell checking. Are you all able to see this? Yes, no, maybe. Everyone. Guys, also auto saving and spell checking I have kept inside the infinite loop. Are they executing infinite times? Are they getting executed infinite times? They are not. At last, at least once are they getting executed, guys? At last, at least once are they getting executed? Yes, Fabian, you are right on that. Also, we are trying to say that hey, you are a secondary thread, background thread. In between, how much ever time you want, you can execute. Guys, garbage collector at the time of Java application execution, in between, if it finds out any referenceless object, will it collect that object from the heap area, guys? Yes or no? Garbage collector will collect, right? That is also a daemon thread. Garbage collector is a daemon thread. But at the end of everything, if everything is over in the application, at last, at least once it will get executed. Because it is a daemon thread. At last, at least once it has to clean everything. Same thing is happening with auto saving, spell checking. At last, they're getting executed at least once. Is that fine to everyone present in the class? How to make a thread as daemon? Set daemon, give a priority lower than 5, and task of the thread defined in infinite loop. Because based on the primary loop, how much ever you execute, that many times it will execute. Usually, if you write anything inside the infinite loop, it will execute forever. Infinite number of times, as long as you have a RAM memory. But right now, even though I have defined this task inside the infinite loop, it is not executing for infinite number of times. It is executing only. Are you all there here? Yes. Now, guys, states of thread. Whenever thread you create, it is in a new state. If you start the thread runnable, if it is running state. If it is task is over, dead state. Correct? When the thread will go to the block state, if the required resource is not available, it will come out of the block state if the required resource is available. If multiple threads are stuck in the block state due to the mutual dependency or cyclic dependency of the resources and permanently stuck in the block state, such phenomena is called as deadlock. How to avoid deadlock? Proper using of synchronized keyword. That's all for today's class, guys. Thank you so much for joining me in today's class. We'll meet again tomorrow exactly at 7 a.m. and continue the journey of multi-threading. Lot to be discussed. Though we have discussed so much, but still not yet over. Okay. So lower priority, lower the priority. No, lower the priority than other. Yes. So thank you so much for joining me in today's class, guys. We'll meet again tomorrow exactly at 7 a.m. and continue the journey of multi-threading. Okay, thank you so much for joining me in today's class. Thank you, every one of you. If you have any questions, stay back. I'll share this. It's actually class 2, but I've given class 3 of PDF name, but it's fine. I'll take up your questions after the 2 minutes of sharing the resources with all of you. Okay, allow me 2 minutes of time and I'm open for questions. Even if you're new to the batch, if you have anything to ask, and if anything to be discussed, stay back. Technical, non-technical, we shall meet again. Tomorrow, inter-service communication, guys. Inter-service communication, I might say a show tomorrow, day after tomorrow. And I might also show debugging, how to use Eclipse debuggers and class level locking, object level locking, proper how synchronize is actually working. With the help of background locking, debugging, I'll try to demonstrate, and then inter-service communication. And after which I will tell you what you can also learn from yourself. And then next week, Stream API and 1 or 2 more classes and 3, 4, 5 days of break, and we shall start the Spring Boot journey. Okay. It should be lower than the primary thread, Fabian. First of all, you have to set daemon true or true. That means it is a daemon thread. Apart from that, if the primary thread priority is 4, it should be lower than that. Okay. If the primary thread is 5, Hibernate videos, is it not yet uploaded? What happens if it is above the normal thread? Then it just try to demonstrate here, just try to run. It may not be working as per your expectations. So does not find your system design course on YouTube. Not system design course. I have done design pattern course earlier, but it is not in the YouTube anywhere. But I am recording it. It's in the recording phase, guys. I am involved in some projects. I'm involved in live classes, recording. So my schedule is tight. Continuously, I'm recording. Let's see. It's see every thread will run when other thread is not running. Concurrency means at a time only one thread. But daemon thread will make sure that it will follow the footstep of the primary thread, and at last, at least once, it will get executed as a background thread. What is the batch name, guys? It is Enterprise Java, right? Guys, there are some videos on JDBC is not yet uploaded. JUnit is uploaded, JDBC is uploaded, SQL is uploaded. Hibernate will be uploaded today only, guys. I'll make our team to upload it. Maybe they have forgotten. Okay. Today only they'll upload. And map, someone was asking, I have added inside the collection only. So map also you can find inside the collection, I guess. If not separately, I'll ask them to add. So Hibernate is not added, guys. Today only they'll add. JDBC, they have created the new folder, recorded lectures. So maybe I'll ask them to arrange this. Okay. It is added. In the live lock also dependency of the resources will be there, but they can release, but they cannot release. If it was possible programmatically, I would have shown. And deadlock, whatever I've shown, it is not because of the deadlock. It is because of what you say, string I have used in that way. But just to show you that multiple threads are stuck, I have taken that example. If it was in the range of possibility, I would have coded and showed. They can release, but they'll not release. Here, they cannot release because of block state. That's the reason. That's the difference. It's conceptual, but it see that scenario might occur to avoid that proper uses of synchronized keyword only for that also. But that problem I could not able to show by writing the code right now with this core Java understanding. Are you going to discuss the difference between notify and notify? Both of them are same. We have to understand wait, notify, notify all. Notify all are same. Notify means it will notify only one thread which is there in the wait state. Notify all means it will notify all the threads which are there in the wait state. So if some thread has to come out of the wait state, it has to encounter notify method. So through the notify and notify all, we are informing the threads in the wait state to come out of the wait state. That's it. I'll demonstrate that in the upcoming 2 classes. The next 2 classes we will see on that part. Inter-thread communication. Okay. Right now, intra-thread communication you are seeing. Inter-thread communication we have not seen. Inter-thread means if one thread is there in a different class, one more thread is there in a different class. Thread 1 is there in the class A, thread 2 is there in the class B. Both should coordinate and should get executed. Very exciting it is. Right now, within same class only all the threads are there. Correct? So now, if one thread is executing the class A, one more thread is executing class B. And I want both of them to get executed in coordination. In coordination, I want both of them to get executed. So that's what I have to show in the upcoming class. Inter-thread communication. Producer-consumer problem. Sorry, guys. How multiple transactions simultaneously happen in the banking with a multi-threading? Can you showcase the demo, Saurabh? No, I cannot showcase. I don't have banking application right now with me. But I'll show you the demonstration maybe in the tomorrow's class with some debugging with Core Java. Because in Core Java, I cannot write 2 lakhs lines of code, right? In the bank, whatever 4 lakhs of lines of code, with 200 developers coded for 1 year. Can I show that in 1 hour of class? Is it possible, Saurabh? Like whatever 100 developers are done for 6 months. No possible. But I can show you Core Java example. I'll try to show you in the upcoming class. Okay. Replica of that I can demonstrate. Yes, TR. Behind the scene, predefined threads are already implemented. You need not to create extra threads. Servlets use multiple threads for every request. Behind the scene, Spring Boot uses multiple threads. So we are understanding more on to understand that how multiple things are executing behind the scene. Okay. Stream API next week. We'll discuss the Stream API next week. Monday or Tuesday's class, Stream API. All right, guys. Thank you again for joining me in today's class. Tomorrow, again, continue multi-threading only. You have time. Again, I'm reminding, I have given you tentative dates of Spring Boot also. Till 14th of October, 12 more days are there. Kindly revise Java. Kindly revise Java. Okay. We are getting 1 week or 4-5 days or 3-4 days of time. Subjective. Okay. Because if 14th I don't start now, then the break will be for 10 days. Suppose next week, if I complete that portion on Wednesday itself, then 14th, if I don't start, then it will be next to next week. The gap will be for more than 10-15 days. At that much gap, I think somewhere harmful it will be. To avoid that 14th, so maybe 4 days or 1 week of time. Fine? Yes, sure, definitely. How long does it take until the lecture recording is up for after the lecture? 2 to 3 years of time. It is automated process. 2 to 3 hours of time. Automated process it is. Okay. All right, guys. Thank you so much for joining me for today, tomorrow, 7 a.m. and continue the journey of multi-threading. Thank you so much for being with me in today's class. Thank you, every one of you.